All right, so I'm going to be there, yep. So graphing. Shh. Why am I? But we played with Desmos, or I might have been dreaming. No, we played with our graphic calculators. And any straight line graph will have this form. Y equals mx plus c. Wait, I love that you're writing that down straight away, but just wait a little bit because we're going to add bits to it. So, do you remember what the m stood for?
Slope/gradient.
Well done. Needs a colour change. So that is your slope/gradient. Oh, can't spell slope. It's going to be slop. And it told us some interesting things about our graph. When it was positive, it told us something. And when it was a big value, it also told us something. Can we remember what those somethings were? When the slope was positive, anybody? It went up. In fact, well done. So it would be increasing. So we knew that it sloped that way. And I'm not going to make you write the opposite because I think you would know. If it was negative, it would be sloping downwards and it's decreasing. Okay? If it's a big value, right? What do I mean by big? So basically greater than 1. 2, 3, 5.6, 7.8, right? When it's big, what can we say about the slope? So when m is bigger, right? 1, 2, 3, what happens? Get back to my, remember the slope? It's increasing. So if this was like 1, what would happen if it was 2?
It becomes steeper.
It becomes steeper, that's right. So when it's greater than and when it is more negative as well, right? It becomes steeper. When is it very genteel slope? When it's in between 1 and -1, so like fractions, a half, a quarter, all that sort of stuff. So how do we write in between 1 and -1? Pardon? Yep. So in between, so less than 1, greater than -1. That's in between, all right? And that's when it's less steep. Less steep. And does anyone want to have a go at what happens if m is actually equal to 0?
Isn't it undefined or something?
So close. We're remembering. Well done. So I love that when people say straight line, but aren't they all straight lines? So yeah, we have to say that's going to be a horizontal line. And Aidan just said too that when the slope is undefined, that's when it's vertical. And I'm assuming everybody knows the difference between horizontal and vertical, but now I just think I'll do that. And yes, Aidan, that doesn't look horizontal. I'll do it again. So I meant to put the horizontal under here, but I didn't leave a gap and I didn't want to just squeeze it in, otherwise Aidan would yell at me. So examples of, these are how we write a vertical line and a horizontal line. It's just a quick y equals the constant, whatever it goes through on the y-axis, and the vertical is that. So that point there would be 4, 6. Right? So those are unique lines, vertical, horizontal. So we're sussing. We've recalled our basic y equals mx plus c. I did forget the c part. Do you remember what that was? Really? Oh, no. Anyone? No one's remembered? I'm saddened. This was your y-intercept. Any recollection at all? All right, that's fine. It's where it's going to cut the y-axis. Okay? So m tells us the slope. The c value tells you when it's going to cut the y-intercept. So if you are told this is the slope, this is the y-intercept, you can bang get an equation of a line pretty easily. While we're here, perpendicular. Nice maths word. Perpendicular. Oh, five syllables. Grace, yeah? Close. Right. So great words to know. Oops. And thank you, I would have forgotten. So parallel. So as Grace was telling us, parallel, and we indicate it like that, right? Never touch. And therefore, these would have the same slope. Agreed? Parallel, same slope. Back to perpendicular. Perpendicular. What does perpendicular? Okay, so we've got hither and the perpendicular one smack bang at a right angle. Okay? Now, what can you tell me about their slopes? One obvious thing. Any perpendicular. Would that one be positive or negative? Positive. What's that one going to be? Are they always going to be opposite sides?
Yes.
Is that positive?
Yes.
Is that negative?
Yeah.
Can you draw two perpendicular lines where they won't be one positive, one negative?
No.
That's the only one, all right? We've got 0 and undefined. But otherwise, it's always going to be opposite sign. What else do you notice? If this one this would be quite small, yes? Because it's gentle. What's that one? Is it? Oh, that one it's also quite small because it's negative. I would disagree. So if I said that this was maybe 1/4, what would this one be? Like negative 1/4 would be like that. Would you agree? So this has to be much steeper. Negative 3/4. I'm going to make you count the squares, people. Would it surprise you that it would be -4 here? But if I've got A on B, the perpendicular slope, we flip and we reverse the sign. Are you writing this down? Stop playing with your laptop. In fact, shut your laptop, Finn. I think so. So e.g., if I have 2/3 slope, the perpendicular slope will be flip and reverse the sign, -3/2. It's called the negative reciprocal. If I have a slope of -5, any ideas what the perpendicular slope would be? Oh, well done. 1/5. Because technically, -5/1 is 5. -5. So, state in words the meaning of the equation. We're not bothering. It's just whatever your x value is, we're going to add 3 to get your y value. That's all. Whatever your x value is, you're going to multiply by 5 to get your y value. Are we happy with this? Whatever your x value is, you'll multiply by 2, then -6. So are we all happy? If you wanted to get your y value, what would you do in this case? Switch it out. I'd rearrange and get y by itself. So how do I get x on the other side? -x. And then it's minus the x value, add 5, and we're done. Now, tell me if you remember some of this from days gone by, But can you, just from looking at this, get the rule? I'm going to cut this out and so we can write on it.